So students, now we will be discussing the recurrence relation of Poisson distribution. We have already seen the recurrence relation of binomial distribution during the binomial distribution aspect. Now since we are discussing Poisson distribution, we need to know the recurrence relation even for Poisson, because they might give a question for the exams saying fit a Poisson distribution for the data. And at that point of time, Poisson distribution's recurrence relation will help you a lot. Same as binomial distribution, even Poisson distribution has recurrence relation both for successive probability terms as well as successive frequency terms. Now, in case it is successive probability terms, then the recurrence relation formula becomes P of x is equal to, here students, in Poisson distribution the mean is lambda, so it will be lambda by x into probability of the previous term, that is x minus 1. Whereas students, we will be dealing more with the frequency terms formula, and the frequency terms formula is T x is equal to lambda by x into the previous frequency, that is Tx minus 1. And students, understand the frequency terms formula of Poisson distribution is what we will be using when the question comes fit a Poisson distribution for the data. This is the formula which we will be using after finding out the PMF. We will look into a question regarding the same now. So students, here is a sum based on recurrence relation of Poisson distribution. This is how it will be given for your exams. Fit a Poisson distribution for the following data, and the data is given here. X is 0, 1, 2, 3, 4, 5, 6, 7. Frequency is given respectively here. For understand students here, the first step is nothing but to find out what is n, as well as to find out summation x, and then to find out the mean. So first step students, let us total up the frequency. Frequency n will be equal to, add all these numbers up of f, you need to get the total as 250. Remember students, this is called as the observed frequency which is given to us. What we have to do now is we have to fit a Poisson distribution and find out the theoretical frequency. At the end, the observed frequency total, that is 250, should match with what we have done, that is the theoretical frequency total. Let us see students. Next step is to find out fx. Let us see how to find out fx. Multiply the columns students, f into x. 132 into 0 is 0, 58 ones are 58. Similarly, multiply all of these. This is 68, this is 36, 9 4s are 36, 5 3s are 15. This is 12 and this is 0. Summation fx. Total this students quickly. 0 plus 58 plus 68, 36, 36, 15, 12 and 0. This should come up to 225. So students, the next step is to write x follows Poisson or Poisson distribution along with its lambda, but we do not know what is lambda as of now, so we will write it as lambda itself. Once we get the answer, let us write it here. How to find out lambda? Lambda is nothing but mean, and mean of the distribution is x bar is equal to summation fx divided by n. We got summation fx as 225 divided by n is 250. When you divide it using your calculators, you will get 0.9. What does it mean? It means that the mean of a Poisson distribution is lambda, and lambda is 0.9, and that is what we had to find out. Lambda is 0.9. Once we get the answer of lambda is 0.9, all we need to do is we have to find out the frequency terms, and for this, to find out the first probability term, we always need, students, the probability mass function. Write down the PMF of a Poisson distribution. It is P of x is equal to e power minus lambda, lambda power x by x factorial. Don't forget to write the range. It is x is equal to 0, 1 up to infinity. Without any further delay, students, find out the first probability term, that is P of 0, which is e power minus, what is the value of lambda? 0.9 into 0.9 to the power x is 0 divided by 0 factorial. And how much is this, students? Look into your Poisson distribution tables and look into the value of e to the power minus 0.9. In your statistical Poisson distribution tables, the value should be given to you as 0.4066. I will not write anything else. The reason is 0.9 to the power 0. Any number to the power 0 is 1. 0 factorial is also 1. So the answer becomes 0.4066. But students, we do not require probability terms here. We require the frequency terms, and that is why we will find out the frequency. Frequency is denoted by Px is equal to n into P of x. What is n here? The total of frequency 250 into what is P of x? The first term, that is P of 0. So it is 250 into P of 0 is 0.4066. Therefore, the first frequency term T0, students, is 250 into 0.4066. And how much is that coming up to? Calculated, you should get it as 101.65. Once we get the first term, that is T0, which we get as 101.65. After this, students, the remaining terms, you need not write the entire formula. All you can write is, just write a statement there first saying other, or you can write it as remaining frequencies can be found by using recurrence relation. So the remaining frequency, students, can be found by using recurrence relation, and firstly write the recurrence relation formula. What is the formula for recurrence relation? The formula for recurrence relation says T of x is equal to lambda by x into T x minus 1. That is nothing but the previous frequency. So we will find out T1 is equal to lambda, we have found out 0.9 divided by x is 1 into T of 1 minus 1, that is 0.9 divided by 1 into T 1 minus 1 is 0, 0.9 by 1 is 0.9 into Students, what is T0? Look into the previous number here. T0 is 101.65. Multiply this and find out your value of T1 should be equal to 91.485. Similarly, students, how do we find out T2? T2 is equal to, I will directly substitute looking into the formula now. Lambda is 0.9 by x is 2 now into the previous frequency, that is a T1, we have got 91.485. When we multiply this and divide it by 2, students, we need to get 41.1683. This is what we need to get T2. Similarly, students, what I wanted to do is pause for a while and find out what is T3, T4, T5, T6 as well as T7, and then we can compare your answer with mine and we can see if we are on the same track. So students, these are the values that you need to obtain. T0, T1, T2. These values we found it out. Let us see what is T3. You had to get it as 12.3505. T4 you had to get it as 2.7789. T5 you have to get it as 0.5002, T6 you get 0.0750, and T7 I have just written it 0. I will tell you the reason for it. Now, let us approximate these values. 101.6 approximately 102, this is approximately 91, this is approximately 41, this is approximately 12, this is approximately 2.7 which is 3, this 0.5002 which is 1. When I approximate this, I get it as 0. So students, understand, once we get T6 as 0, definitely when we come to the next successive term, the value doesn't increase. So what you need to do is, once we get T6 as 0, immediately you should know that even T7 is automatically 0. Now since we have got all these values, students, the final step is to write the conclusion. For the conclusion, students, we need to write x 0, 1, 2, 3, 4, 5, 6 and 7. This was the data given to us in the question. Along with this, they had given us even another column called as observed frequency. They had not given us observed frequency, they had just given us frequency, but understand students, that is called as observed frequency. And if you look into the questions, you can just copy down the same values. If you remember, 132, 58, 34, then the value given to us was 12, 9, 3, 2 and 0, and this total, students, came up to 250. Now, we also calculated later using Poisson distribution, that is nothing but the theoretical frequencies. So, do another column and write there theoretical frequency. And what did we get? When it was T0, we got it as 102. For the next, we got it as 91. Then we got 41. Similarly, 12, 3, 1, 0. And the last one also we got 0. But what matters is the final total. The total even of the theoretical frequencies, when you add 102, 91 and all these numbers, you need to get it as 250. Students, this is the sum which usually comes for the exam, saying fit a Poisson distribution to the given data. We have fitted the Poisson distribution to the given data, used a recurrence relation, and by this we conclude the aspect of Poisson distribution.